I am liking this chemistry math connection I've got going on right now. So I just looked up the word polymer on Wikipedia, the source of all truth, wisdom, and knowledge. That was sarcasm. I mean, it's good enough, but don't rely on Wikipedia for everything. So a polymer is a large molecule composed of many poly, right? Poly meaning many repeated subunits. So it takes these little subunits and puts them all together to make many bigger units, or a polymer. Now, this is cool though. The subunits are called monomers. Mono meaning one. So this is so much like math, right? So in math we have the monomial, which is a single mathematical term, and we put those together to make polynomials, which are bigger, many monomial terms. And in chemistry, we have monomers being put together to make polymers. Monomers being grouped together to make polymers. That's good. Okay, good stuff. So let's look at some polynomials. Add and subtract polynomials using algebra tiles. Once again, I've got these tiles that I can use to represent algebraic expressions. Here we go. Remember that monkeys like to play with monkeys. X's like to play with X's. X squareds like to play with X squareds, right? So we just have to make sure we add the correct terms together. And also remember what the boom boom does. Remember the boom boom? If I have X minus negative X, boom, boom, right? The two negatives in a row become a positive. So let's do a problem with this. Now, first off, I want you to notice that here's the actual expression up here, and it's been modeled. So I have 8 x's, 1, 2, 3, 4, 5, 6, 7, 8 x's plus 6, 1, 2, 3, 4, 5, 6. That's good. Plus 4 x's, 1, 2, 3, 4, and 3. There we go. So let's combine it. There's no boom boom involved here because it's a plus, but I have what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 x's. That's 8 x's plus 4 x's. That's 12 x's. And I have 1, 2, 3, 4, 5, 6, 7, 8, 9 plus 9 air bubbles. 6 plus 3 is 9. That's it. Now this one's subtraction. And I want you to see this. There's a boom boom right here. See this? Negative, 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 negative. This actually becomes a positive 1. A positive 1. A positive 1. So what do I have? I have 1, 2, 3, 4, 5 x's subtracting 2 x's. What's 5 x's? Subtract 2 x's. That's 3 x's. And look at it right here. 5 x's minus 2 x's would be 3 x's. Now I have negative 1, negative 1. I have negative 4 plus 3. What's negative 4 plus 3? Negative 1. Right? Negative 4, look at it right here. Negative 4, boom, boom, plus 3. Negative 4 plus 3. Let's do one more. Actually, let's do 2 more. Now, let's use this boom boom. Watch this. I have 1, 2, 3, 4 x's minus 5, right? Minus 3 x's right here. Now, plus 5. Because negative, negative 1 becomes a positive 1. Negative, negative 1 becomes a positive 1. And isn't that what I have here? The other thing is, you see this negative? I can distribute it across. It runs through. This is negative 3x plus 5. And that's what I was modeling. So this expression up here is modeled right here, right here. So I have 4x's minus 3x's, that's x, and I have negative 5 plus 5, that's just 0. Done, it's just x. Now the goal is to get away from the tiles and be able to do it without tiles. So let's look at this. I have negative 9x. I'm going to look right up in here. Negative 9x plus 9 plus 5x. Why did I put a plus? Because of the boom boom. And this negative is going to run through and change that into a negative 1. We'll see. 1, 2, 3, 4, 5, 6, 7, 8, 9. Negative 9x plus 9. 1, 2, 3, plus 9. Negatives, these all become positives because of the boom boom, and that becomes a negative 1. So I have negative 9x plus 5, that's negative 4x. 9 minus 1, positive 8. There it is. And you did not see what I just wrote. There you go. All right, so that was polymer. Polymer. Oh, styrofoam is a polymer. To natural biopolymers such as DNA and proteins, DNA is a polymer. It's a biopolymer, so it's not a plastic, or it's not man-made. Interesting. Okay, hey, that's it. Thanks for watching. Bye-bye.